All right, so the planets, as I was saying, move from the western direction towards the eastern direction. This isn't something. Yeah, okay, so let me make sure that everyone understands this. It's not something that happens in one night. You'll never see this in one night. It's when you compare the planets to some distant star and you go so if you were let's say you had a really bright star, and the planet is really close to I'm going to use this example right here. So there's Mars. It's right next to this particularly bright star, and over the course of months, okay, so months have to go by, you would notice, if you went out and you watched Mars over and over and over again, it would slowly um, move to the east. All right, and that's true with all the planets. Okay, that's what the moon does. That's what the sun does. Of course, it's because everything's going around the sun in a counterclockwise direction. All right, so that's. I mean, now remember, the Greeks didn't necessarily know that that was the situation. Uh, and the other thing is, you have to understand that even though Aristarchus was proposed that the sun was the center of the solar system, um, it was Aristotle that won the day, and for you know 1,500 plus years, Aristotle's ideas were the ones that dominated. And so Aristotle felt that the sun was just going around the earth, that the earth was still and everything moved around the earth. And by the way, that's called the geocentric model. And when everything goes around the sun, that's called the heliocentric model. We'll see that in just a second. All right, so this business with the planets, right? The planets, whether you're talking about the geocentric model or the heliocentric model, the planets move, over time, over the course of months, from the eastern direction in the sky to the western direction in the sky, and they always follow the ecliptic, right? They you find them in the constellations of the zodiac. All right, so all right, now then there's a little bit of there's yeah, okay, before we get to that, the apparent motion of the planets um, is usually from west towards east relative to the stars. Um, so that's just the normal situation that takes place. However, there are special times, and the Greeks could not predict when this occurred, but there were times, and again, it takes a long time, months and months for this to occur. Let's say you have a planet, it's moving along. This is a much more modern situation. So here's Mars moving along, moving. So this is, to the right over here. This is the west. To the left is the east. So the planet is moving to the east over time, and then suddenly, for no apparent reason, although there is a really good reason for this, and I'll get into that shortly, um, the planet starts to move westward. All right, so that westward motion is different, right? The planet suddenly moves westward, and what I mean by that, of course, is it's moving westward with respect to the background of stars. Like Antares, for example, is a really bright star. In Where is that in? I think in the constellation Scorpio. Just anyhow. Um, that doesn't matter, but that's a very bright star, and so during this time, or around this time here, in February, it, it it was moving um, Mars in particular, it was moving towards the east as it usually does. Then suddenly it seems to go backwards, moving to the west. And by the way, that is called retrograde motion. So anytime the planets are moving to the west, that's considered retrograde motion. Retrograde is just kind of a backwards motion, right? And so now, the Greeks knew about the retrograde motion. They couldn't explain it very well, but they tried. They tried to explain it, um, and they came up with some different models, as we're going to see. All right. So and then after about a month or so, the planet starts moving back to the east again, but it's the westward, the backwards, or the retrograde. I'll just keep using retrograde, right? The retrograde part seems very odd. And so, like I said, this is not something you see in one night. You have to be very careful. Like you got to sit there and you plot the motion. You look at the background of stars, which is more or less fixed, right? And then you plot the positions of the planets, and you find that they're wandering throughout the night sky. But they mostly wander from the west towards the east, and then this motion right here, this retrograde motion, became very interesting to the Greeks, and they tried to explain it. I mean, that's what we do in science. We try to explain things. We explain observations that we make about nature. All right, so because of the general east-west motion of objects in the sky, the geocentric model is what was developed, right? So you have this overall from west to east motion. This guy Eudoxus, so this is again, he's not very well known or anything, but he proposed a geocentric model. He's the first one that we know of. So this is before the time of Aristotle. He proposes this, and it gets by most people, it gets adopted as the model that everybody starts using. Of course, we know that Aristarchus didn't use this, but his ideas were kind of put on the bookshelf, and really, it was we know that this person proposed this, but it's really Aristotle and his popularity that propelled this well into the Middle Ages, right? You go into the Middle Ages, and people still believed in the geocentric model. So the faster an object moves in the sky, the smaller its corresponding sphere. So we're talking about the celestial spheres that they imagine these different celestial spheres surrounding the Earth, and so something that's moving fast. That was a smaller celestial sphere. So the simple geometric model, right? Or, I'm sorry, geocentric model could not explain retrograde motion, right? So if you just kind of lived in this geocentric model situation, you can't explain that westward motion. Why would the planets suddenly stop and then let me go back to this? The planet would suddenly stop. Oh, but by the way, it slows. So if you were to observe this, it slows down and then stops and then goes backwards and then slows down, stops, and then goes forward. Okay, so that's all right. Now, planets don't do that, of course. This is just an optical illusion. I'll show you why in just a little bit. All right, so this is the geocentric model in all its glory. There's the Earth. The moon moves fastest, and by the way, you never see the moon or the sun undergoing retrograde motion. Just keep that in mind for a little bit. It's only the planets only these 5 objects that undergo retrograde motion. All right. So this is actually this is after Christ. The Ptolemy was he lived in Alexandria. Okay, so very similar to not during the time of Aristophanes. This is much. Um, I think it was about 200 years after Christ. Anyhow, Ptolemy comes along and he proposes a model that fits with the geocentric model, right? So the Earth is the center, and the planets are going around. All the planets and the moon and the sun, they're all going around the Earth. But he throws in this this thing called the epicycle. And then there's other thing. There's a thing called a deferent as well. But we'll just get into the epicycles. So I mean, by the way, this is wrong. Okay, so let's start out with that. As we know that this is not true. But the thing about this was Ptolemy comes up with this model, and it works. Okay, for the most part, it works, right? For naked eye observation, not for telescopic observation, which wasn't to happen for another more than 1,000 years, but for just looking at the planets and looking at the stars with our eyes and mapping where the planets are, this idea of the epicycles works. Okay, so this is the basic idea: is the planets going around the Earth? That's in its good geocentric model way, and then but the planet, for some bizarro reason, is going in a little circle in and of itself. So it's going in this little circle, and then that circle is following the bit. It's kind of like a spirograph. If you ever had a spirograph as a kid, and you turn the circle within circles. So that's all an epicycle is. It's a circle within a circle. But see, what the nice thing about this, the thing that the brilliance of it, I mean, it really is a brilliant model, is that there are times during when the epicycle causes, like if you think about it, if it's going in a little circle, there's times when the planet would appear to go towards the west and then go back towards the east, because of this thing called the epicycles. Right, so that was Ptolemy's explanation of retrograde motion, and this lasted for more than 1,000 years, right? Because there were no telescopes to disprove it. The one thing I will say about the epicycle is the thing that the reason it lasts for about 1,000 years is within a human lifetime, which is maybe 80 years. I mean, even back then it was even less. But during a human lifetime, 70 years, whatever the average was back then, this worked pretty well. And then what happens is after 100 years, 200, 300 years, his system of epicycles you wouldn't be able to predict where the planet was. The planets were not in the right position. So for during one human lifetime, this worked out pretty well. But then when hundreds of years pass, it doesn't work. It breaks down, and so then you have to make new observations, and then people did that, and then they used the epicycle model because that's the best thing that they had. All right. So let me say something about Occam's razor. That's a very common thing that's used. If you can explain something and it's simpler, usually the simpler explanation is the one that is true. All right. So Ptolemy, like I said, it's a brilliant idea. It's just wrong, right? It turns out to be completely wrong. The planets don't go around the Earth. They go around the